In this example, we're going to look at what a change in temperature would affect an equilibrium system. For Le Chatelier's principle, when you're examining changes in temperature, you first have to consider whether the system is an exothermic system or an endothermic system. That's the very first question you need to ask when you're changing the temperature for an equilibrium. Another thing to remember that could help you figure out the shift direction a little more easily is you could think of heat as either being a product or a reactant. It would be a product in an exothermic reaction. Heat would be a reactant in an endothermic reaction. Finally, and this is different compared to changes in volume or concentration, when you change the temperature of an equilibrium system, the equilibrium constant value will also change. However, when you change a concentration or a pressure or volume, the equilibrium constant remains the same. So this is the only situation where the value of K will change. So let's look at two examples. In this first example, A and B react to form D. And we're given the information that the change in enthalpy is a positive 72 kilojoules. If that's a positive 72 kilojoules, that means that this is an endothermic reaction. If it's an endothermic reaction, that means that heat is being added into the system, so heat can be treated as a reactant. So, if the temperature changes by increasing, so if the temperature is increasing, that means that we have more of this than we need. And so in an endothermic reaction, the system will shift to remove that extra heat. So in this situation, it will shift to the right. Now, what would be the effect on the value of the equilibrium constant in this case? If the reaction is shifting to the right, that means we're producing more of the product and we're using up or decreasing the amounts of the reactants. So the concentration on the numerator side is getting bigger. The concentrations on the denominator are getting smaller. So that means that K increases if you increase the temperature in an endothermic reaction. Now let's look at the example for increasing the temperature in this second equilibrium system. It looks very similar to the other one, but the difference is that the delta H in the second equilibrium is a negative 64 kilojoules. That means that this equilibrium is exothermic. If it's exothermic, that means that heat can be treated as a product in the equilibrium. So if we're increasing the temperature, that means we're getting more heat than we originally needed. And so Le Chatelier's principle predicts that we will shift to remove that extra heat. So this system will shift to the left to remove that extra heat. Now, what's going to happen to the value of the equilibrium constant when we increase the temperature in an exothermic reaction? The products are getting smaller. The reactants are getting larger. So the numerator is decreasing, the denominator is increasing. So that means that for an exothermic reaction, the value of the equilibrium constant decreases when you increase the temperature of the system.